let's introduce the Moivre's theorem. If I want to raise z equals 1 minus radical 3i to the power of 3, so I need to find z cubed. Keeping z equals 1 minus radical 3i in algebraic form is messy. So we need to write the number in polar form. Z equals 1 minus radical 3i, so r equals radical 1 squared plus minus radical 3 squared equals 2. Theta equals tan minus 1 minus radical 3 over 1 equals minus pi over 3. So z equals 2 cosine minus pi over 3 plus I sine minus pi over 3. So this form separates the modulus from the angle, and that's what we need to apply the Moivre's theorem. If you want to know more about how to find theta and to put it in the correct quadrant and in the correct interval, check my other video from Cartesian to polar form. The Moivre's theorem is a powerful tool in the world of complex numbers. This theorem is going to make it easy to raise complex numbers to integer powers, and it's a key step in finding roots of complex numbers. So let's see the formula. For any integer n, if we raise r cosine theta plus I sine theta all to the power of n, we will get r to the power of n cosine n theta plus I sine n theta, which means that we raised the modulus to the power of n and we multiplied the angle by n. So here we stretch the modulus and we rotate the angle. Since we found z in polar form, let's apply the Moivre's theorem to find z cubed. So z cubed equals, I'm going to raise r to the power of 3 and multiply the angle by 3. This gives me 2 cubed cosine 3 times minus pi over 3 plus I sine 3 times minus pi over 3 equals 2 cubed cosine minus pi plus I sine minus pi. Here we simplified. So z cubed equals 8 into cosine minus pi plus I sine minus pi. This is the polar form. Or z cubed equals minus 8, and this is algebraic form. Now, since we have z in polar form and in algebraic form, and we found z cubed in polar form and in algebraic form, let's understand the geometric representation behind them. If we want to plot z equals 1 minus radical 3i on the Argand diagram, so z will be a point at 1 minus radical 3. And if we try to sketch z on the polar system, so at an angle of minus pi over 3 with magnitude 2, we will find z. On the other hand, if we try to sketch z cubed equals minus 8 on the Argand diagram, so we will find point z cubed at coordinates of minus 8 and 0. And if we try to sketch it on the polar system, so here we did 3 rotations of minus pi over 3. So we did minus pi over 3, and again minus pi over 3, and again minus pi over 3. And this is the idea behind multiplying the angle by 3. So 3 rotations of minus pi over 3, we reach minus pi. So z cubed can be found at an angle of minus pi with magnitude 8. Let's take another example. Given z equals half minus half I, let's find z5. R equals radical half squared plus minus half squared equals radical 2 over 2. Theta equals tan minus 1 of minus half over half, and this is equal to minus pi over 4. The angle is in the right quadrant. Now z equals radical 2 over 2 into cosine minus pi over 4 plus I sine minus pi over 4. This is the polar form. Now let's apply the Moivre's theorem to find z5. So Z5 equals radical 2 over 2 all to the power of 5 into cosine of 5 times minus pi over 4 plus I sine 5 times minus pi over 4. Z5 equals radical 2 over 8 cosine minus 5 pi over 4 plus I sine minus 5 pi over 4. This is the polar form of Z5. Or Z5 equals minus 1 over 8 plus 1 over 8i. We can use the calculator to turn this into algebraic form. How to apply the Moivre's theorem to the product of two complex numbers. If Z1 equals R1 into cosine theta 1 plus I sine theta 1, and Z2 equals R2 into cosine theta 2 plus I sine theta 2, then Z1 times Z2 equals R1 times R2 into cosine theta 1 plus theta 2 plus I sine theta 1 plus theta 2. So here we multiply moduli and we add arguments. And this is the Moivre's theorem for the product of two complex numbers. Let's apply this rule. If Z equals 1 minus radical 3i and W equals half minus half I, let's find Z times W. Step 1, we need to convert to polar form. So Z equals 2 into cosine minus pi over 3 plus I sine minus pi over 3, and we found this before. W equals radical 2 over 2 into cosine minus pi over 4 plus I sine minus pi over 4, and we found this before. Now, the formula, let's apply the Moivre's theorem for Z times W. We are going to multiply the magnitudes and add the angles. So Z times W equals 2 times radical 2 over 2 into cosine minus pi over 3 plus minus pi over 4 plus I sine minus pi over 3 plus minus pi over 4. So Z times W equals radical 2 into cosine minus 7 pi over 12 plus I sine minus 7 pi over 12. And this is the power of the Moivre's theorem. We apply the formula directly. Now, let's apply the Moivre's theorem for the division of two complex numbers. If Z1 equals R1 into cosine theta 1 plus I sine theta 1, and Z2 equals R2 into cosine theta 2 plus I sine theta 2, so by dividing Z1 and Z2, we will divide the moduli as well. So R1 by R2 into cosine theta 1 minus theta 2 plus I sine theta 1 minus theta 2. So here we divide the moduli and we subtract the arguments. Let's take an example. If Z equals 1 minus radical 3i and W equals half minus half I, let's find Z over W. So step 1, we need to write in polar form. We already found Z and W in polar forms, so Z equals 2 cosine minus pi over 3 plus I sine minus pi over 3. W equals radical 2 over 2 cosine minus pi over 4 plus I sine minus pi over 4. Let's apply the Moivre's theorem for Z over W. So, for Z over W, we will divide the magnitudes and we will subtract the angles. Dividing the magnitudes gives us 2 over radical 2 over 2 into cosine minus pi over 3 minus pi over 4 plus I sine minus pi over 3 minus pi over 4. So Z over W equals 2 radical 2 into cosine minus pi over 12 plus I sine minus pi over 12. And this is the polar form by applying the Moivre's theorem. So what's the next step? If you'd like a clean PDF notes I used in this video, you can find them in this link with my other further math resources, so you can choose the Moivre's Foundation Notes.